Okay, so let's start, no? So sa group ni Maui, no? So sila yung discuss ng discrete probability distribution. So bago magsalita yung mga members, magpakilala muna kayo para alam ko.
Start na po, sir?
Yep, tapos magpakilala muna bawat isa bago pag part na ng report nila para alam ko.
Good afternoon, everyone. I'm Maria Carmela Villarosa. Today, we will present and discuss the discrete probability distributions. So before we start, our learning objectives is, at the end of the topic, the learner will be able to, first, determine and define a discrete
Nakalimutan ko,
probability
on-cam pala, on-cam.
Wait lang po, sir.
Para po pag walang cam.
Ano ba yan? Sige na, on-cam na. Game na, ano? Maui.
Our learning objectives. So at the end of the topic, the learner will be able to, first is to determine and define a discrete probability distribution. Second is to calculate probabilities for some common discrete probability distribution. Third is to differentiate between the binomial and Poisson distribution. And last is to understand the assumptions for some
That is,
common discrete
Poisson's distribution. Poisson's.
Poisson's. Sige.
Nawala. Sino na yan? Kanino na yan?
Kay Kelly Ramirez. So random variables and probability distribution. A random variable is a variable that can take on different values according to the outcome of an
Kala ko
experiment.
kay Ramirez yan.
Wala, hindi ba ito naririnig sila?
Nag-comment eh. Ramirez, nasan ka?
Sir, hindi daw po siya marinig.
Baka naka-mute. Wala, Ramirez. Saglit. Tingnan ko. Yan, pakitry. Pakitry na, Ramirez. Sabi ko, test kanina eh.
Sir, dinig na po.
Yan.
A random variable is a variable that can take on different values according to the outcome of an experiment. Random variables are either discrete or continuous. A random variable is discrete if it can assume on only a countable number of possible values 0, 1, 2, 3. A continuous random variable assumes an uncountable number of possible outcomes. It can take on any value in one or more interval of the values. A function of a discrete random variable that gives the probability that the outcome associated with the variable will occur. The two key properties of a probability function are: one, 0 less than or equal p of x less than or equal 1. Number two, summation of p of x equals 1. That is the sum of the probabilities for all possible outcomes. X for a random variable x equals to 1. Collectively exhaustive events are events in which all possible outcomes are included. The probability distribution of a random variable x is a description of the probabilities associated with the possible values of x. For a discrete random variable, the distribution is often specified by just a list of the possible values along with the probability of each. For other cases, probability is a random variable or stochastic variable. It is a variable whose value is determined by a random experiment. It is usually denoted by a capital letter such as X or Y. For a given sample space of some experiment, a random variable is a rule that associated a number with each outcome in the sample space.
Hello, rinig po ako.
Yep, magpakilala ko muna.
Hello. My name is Cyrus Miranyo po, and I'm going to report this part. So now let's have an example on how to solve random variable using probability distribution. When the two coins are tossed, the possible outcomes are head and head, head and tail, tail and head, or tail and head, tail and tail. If x is the random variable, let's solve for the number of tails. So first, hanapin muna natin yung number of tails sa kada possible outcomes na nakuha natin. So, sa tails and tails, may nakuha tayong dalawang tails kaya ang value of random variable niya ay 2. And sa tails and head at head and tails, may nakuha tayong isang tails kaya same silang 1. While sa head and head is wala kaya 0. After that, mawi yung table. Yung table na. After that, we can list down na sila sa probability distribution table. So, sa first row is nakalist down yung mga value of the random variable which is 0, 1, and 2. While sa second row naman is the probability of each random variable. So, sa random variable na 0, which means yung wala kang nakuha tails is 1/4 kasi sa apat na possible outcomes, iisa lang yung walang tails. Samantalang sa 1 naman is 2/4 kasi dalawa yung sa apat na possible outcome is dalawa. Then sa 2 naman, 1/4 din since isa lang yung may dalawang lumabas na tails. Then next slide. So dito naman tayo sa conclusion. So sa A, what is the probability of getting 0 tails? The probability of getting 0 tails is 1/4. And sa B naman, the getting of 1 tails, the probability of getting 1 tails is 2/4. And the probability of getting 2 tails is 1/4. So overall conclusion, each probability of random variable which is the tails is between 0 and 1. And the sum of all the possible possible probabilities is 1. So next slide. For a discrete variable x with possible values x of 1, x of 2, and so on and so forth, a probability mass function is a function that the first condition is function of the ith value of x is greater than or equal to 0. And the next is the second condition, the summation of ith value of x must be equal to 1. And the third and last condition is function of the ith value of x must be equal to the probability of x equal to the ith value of x. So, yun lang.
Ako po si Gabriel A. Vasquez, sir. At yung next part naman po is cumulative distribution function. Cumulative distribution functions is an alternate method for describing random variables. Probability distribution is with cumulative probabilities such as P probability of X less than or equal to X. Furthermore, cumulative probabilities can be used to find probability mass function of a discrete random variable. The cumulative distribution function of a discrete random variable X is denoted as function X. Is f of X is equivalent to probability of X less than or equal to lowercase x. Yung sa formula po kanina, ito yung mga meaning ng bawat value doon. F of X is
Tawag na ano, nomenclature.
ano po, sir?
Nomenclature, yung mga meaning ng
Nomenclature.
kada parameters. Nomenclature.
Nomenclature. Thank you po, sir. Yung f of X is the function of X. X is the real value variable. P is the probability that X will have less than or equal to X. For a discrete random variable X, f of X satisfies the following properties. The first properties is f of X is equivalent to probability of X is less than or equal to X. And the second one is 0 is less than or equal to f of X. And f of X is less than or equal to 1. The third
Mali,
probability
basa mo,
is...
mali. Wait. Yung
Sige po,
second is, ang basa niyan from, mag-umpisa ka doon sa
From-
right. So, f of X,
Sa 1 po.
that is less than or equal to 1. But,
But.
naka-mirror yan eh. But, greater than or equal to 0. So, meaning, between 0 to 1 yan.
Sige po, sir. And yung pangatlo naman po is if X is less than or equal to Y, then function of X is less than or equal to function of Y. Ito naman po yung sample problem 2, which is magre-refer na po sa unang problem na nakita kanina. Tungkol po sa heads at tails. Which is P of X is equivalent to 0 ay ang value niya is 1 over 4. Probability ng 0 po. At probability po ng 1 is 2 over 4. And ang probability po ng 2 is 1 over 4. So sa first condition, which is probability of X is less than or equal to 0, which is ang isa lang mapapakita is probability of 0, which is 1 over 4. Kasunod na condition, probability of X is less than or equal to 1. Ang masasama naman dyan ay probability of 0 and probability of 1 na ipag-add together, which is 1 over 4 plus 2 over 4. Ang equivalent po ay 3 over 4. Sa pangatlong condition naman is P is probability of X is less than or equal to 2. Ang probability ng 0 at probability ng 1 at 2 pagsasama-samahin, which is 1 over 4 plus 2 over 1 plus 1 over 4. Ang kinalabasan ay 4 over 4 at ang equivalent nun ay 1 po.
Ayun. So, nakadefine dyan sa function kung ilan yung nasa parenthesis ng probability. So, meaning usually, kung X is less than or equal to 10, so meaning from 0 to 10, ipag-add yung probability. So, depende yun sa magiging condition ng problem. So, since yan kasi sa dice, 3 lang yung ginawang condition. Pero minsan, yung mga condition kasi minsan up to infinite. No? So, I think may nakita akong generic formula niyan eh. So, yung ako madidiscuss. Sige, tuloy na.
Hello po. My
Yep.
name is Joyce Tamparong. Ako po yung magre-report sa expected values of random variable. The
Anong name?
expected value of Joyce Tamparong.
Anong ulit ni? Joyce. Okay, sige, sige.
The expected value of a random variable is denoted by capital E of X. The expected value can be thought of as the average value attained by the random variable. In fact, the expected value of a random variable is also called its mean, in which case we use the notation mu of X. The formula for the expected value of a discrete random variable is this. Capital E of X is equal to summation of X multiplied by P of X. Next slide. Then, connected to sa expected value, the variance of a random variable X is denoted by either V or X or sigma squared X. The variance is defined by sigma squared X is equal to capital E of X minus mu X squared. This is the expected value of the square difference between X and its mean. For a discrete distribution, we can write the variance as sigma squared equals to summation of X minus mu squared multiplied by P of X. Next squared. Next. Standard deviation. The standard deviation of a random variable is the square root of its variance and is denoted by sigma x. Generally speaking, the greater the standard deviation, the more spread out the possible values of the random variable. Sigma is equals to variance, sigma is equal to square root of variance. It is summation of x minus mu squared multiplied by p of x. Next slide. Sample problem 3. Determine the mean, variance, and standard deviation of the following problem. Mass function. So yung given is x and then p of x. Yan. Para makuha yung x, multiply by p of x is yung x at saka yung p of x is pag multiply lang siya bali ano siya 1 1 times 0.15, 2 times 0.25, and 3
So parang
times
yan ang ginawa natin nung statistics natin last time, di ba? So yung formula parang breakdown natin sa table para mas madali.
Yes, sir. And then yung dulo niya, yung 2.95, ipag-add mo lang siya lahat. Tapos, bale, ito na yung pinaka mean ng problem. Mu. Bala kayo kung anong gusto nyo tawag, mean or mu. And then,
Tama.
ito na yung pinaka-mean ng problem is yung 2.95. Then the next column is yung x minus mu. Yung x sa column 1, ima-minus mo siya sa mean, which is yung 2.95. 1 minus 2.95 is equal to negative 1.95, and 2 minus 2.95 is equal to 0.95. Hanggang dulo siya. Parang ganun, basta ganun. And then, x minus mu squared is yung x minus mu sa fourth column, i-squared lang.
Okay, sige.
I-squared lang siya is yung negative 1.95 squared is equals to 3.8025. Yan.
Yep.
Ganun lang siya.
And so on and so forth.
And so forth. Then, sa next column, yung last column, ito yung variance. So, hindi mo makukuha yung variance pag hindi mo pa nakukuha yung mean. X minus mu squared multiplied by p of x. Yung p of x sa second column, i-multiply mo siya dito sa second to the last column sa x minus mu squared. 0.15 times 3.8025 is equal to 0.5704. And 0.25 is equal to 0.25 times 0.9025 is equal to 0.2256, and so on and so forth. Ito yung pinaka-variance, yung nasa dulo, yung 1.8476. Para makuha yan, ipag-add lang lahat yung nandyan sa column. tapos ito yung lalabas is 1.8476, ira-round off siya sa 1.85. Para makuha yung standard deviation, pinaka-last, yung standard deviation, square root lang siya. So, square root ng 1.85 is 1.36. And that's it.
Okay, nice, nice. Parang ganun nga yung standard deviation, dadaanan din natin yan, di ba? Pero since iba yung topic dito. So, nag-vary din. Depende na din sa mga expected variance and outputs. Okay, next, reporter.
Next po is the Bernoulli distribution. The Bernoulli distribution is the distribution of the numbers of successes on a single Bernoulli
Hindi ka na ba
trial.
yung Carmela? Diba? Sa'yo na pala. Okay, sige.
Second is, in a Bernoulli trial, we get either a success or a failure. The number 3, P of success is equals to P, and P of probability of failure is equals to 1 minus P. For example, we can use the Bernoulli distribution to answer a question like this. Toss a pair coin once. What is the distribution of the number of heads? So, we're gonna let the random variable x is equals to 1 if a success occurs, and x is equals to 0 if a failure occurs. And if these conditions hold, then x has what called the Bernoulli distribution, where the probability of x is equals to p raised to x times 1 minus p raised to 1 minus x, for x is equals to 0 and 1. Ipaghiwalay po natin sila. So, probability of x minus 1 is equals to p raised to 1 times 1 minus p raised to 1 minus 1. So, ang magiging sagot niya po is p small p. Then, for the
Kasi
zero
ano na yan,
probability,
mga parang factoring sa property na ng exponent. So, P na lang talaga yan. Kasi magiging 1 na lang ito eh. So, P raised to 1 is P. So, tama.
tapos po,
Then,
probability of x is equal to 0 is equals to p raised to 0 times 1 minus p raised to 1 minus 0 is equal to 1p, 1 minus p. P raised to 0 po is equals to 1 times 1 minus p, tas 1 minus 0 is 1, then 1 minus p raised to 1 is yun lang din po. Then 1 times 1, 1, tapos 1 times negative p is negative p. Kaya po ang matitira na lang po ay 1 minus p. Where p is the success and the 1 minus p is the failure.
para siya yung complement na diniscuss natin nakaraan, di ba? So, yung P yung success, tapos yung kabaliktaran naman is failure, which is ma-minus mo lang yung P sa 1 or 1 minus P.
Yung Bernoulli trial po is answerable po ng parang yes or no or 0 and 1.
Yep, tama. Sige, continue. Kanino na to? Binomial distribution.
Arjun po, Mesa.
Parang hindi ko nakita si Mesa dito. Nandyan ba? Hindi ko nahalata yung name niya kanina.
Nakalala po. The binomial distribution. A random experiment consists of n Bernoulli trials such that yung pong diniscuss natin kanina sa Bernoulli trial, first is the trials are independent. Second is each trial results in only two possible outcomes labeled as success and failure. And then third is the probability of success in each trial is denoted as P and remains constant. The random variable of x that equals the number of trials that results in a success is the binomial random variable with the parameter of p less less than to 1 but greater than to 0, and n is equals to 1, 2, and so on and so forth. The probability mass function of x is denoted as probability of x is equals to n nx, or that is the combination po,
Yep,
times
combination
p
ng
raised
X yan.
yes po, times 1 minus p raised to n minus x. Where p is equals to the binomial probability, x is the number of a specific outcomes within the n trials, n of x is equals to the number of combinations, p, small p is equals to probability of success on a single trial, and 1 minus p, pwede din po siyang maging q sa iba pong formula, is equals
Sa
to
ibang
probability
reference. Tama.
of failure on a single trial.
Kahapon
Then
ang ginamit
n is,
namin. Sige lang, okay lang. Tuloy na.
then n po is equals to the number of trials.
Hi po, good afternoon. My name is Isabel V. Miranda and I will be solving a problem so we can appreciate more about binomial distribution and learn about geometric distribution. Hi. A coin is tossed 12 times. What is the probability of getting exactly 7 heads? In problem solving, it's always easy to begin with finding the given, starting with n, or the number of trials, which is 12. Given that a coin is tossed 12 times, the probability of getting a head in a single toss is 1/2 because there's only one head on the two sides of a coin. So p is equals to 1/2. Getting the probability of failure is 1 minus p. 1 minus 1/2 is equals to 1/2. So q is equals to 1/2. Now we must find the probability of getting exactly 7 heads, stating x is equals to 7. Having these values and the formula of binomial distribution, which is p of x is equals to number combination times p raised to x times q, or 1 minus p raised to n minus x. Now, next po. Okay, substituting the values of formula, we get p of x is equals to 12 combination 7 times 1/2 raised to 7 times 1/2 raised to 12 minus 7. First, solve the number combination so the formula doesn't get too long, where 12 combination 7 is equals to 12 factorial over the factorial of 12 minus 7 times 7 factorial is equals to 792. Next po. Okay, proceeding to p of 7 is equals to 792 times 1/2 raised to 7 times 1/2 raised to 5. Now you can just throw it in scientific calculator and you will have 0.193 times 100 because we're looking for the percentage. Therefore, the probability of getting exactly 7 heads in tossing a coin 12 times is 19.3%. Next po. Moving on to geometric distribution. In a series of Bernoulli trials, the random variable x equals the number of trials until the first success is geometric random variable. In other words, the geometric distribution is just a more restricted version of binomial distribution that requires the same condition in order to be used. Kasi sa binomial distribution, you are finding the probability of getting a certain number, X successes, while geometric distribution, you're finding the probability of getting the first success on on a trial number. Using, di pa po tapos. Balik po. Using the
May
formula
spoiler.
of f of x, using the formula of f of x is equals to 1 minus p, or the q, raised to x minus 1 times p. Yun lang po. Thank you.
Next, sige. Negative
So for
binomial.
the negative binomial distribution, in a series of Bernoulli trials or independent trials with a constant probability p
Ano pa rin yan, ano?
success.
Carmela?
Kay Arjun po yun. Wala po eh.
Ang pangalan?
Mesa po.
Kay
Arjun.
Arjun pa rin? Okay, mesa pa rin. Okay, sige.
The
Sinaliw mo
random
pala.
variable that equals the number of trial until r successes occur is a negative binomial random variable with the parameters of p less than to 1 but greater than 0, and r is equals to 1, 2, 3, and so on and so forth. So for the negative binomial distribution is denoted as function of x is equals to x minus 1 over r minus 1 times 1 minus p raised to x minus r times p raised to r, where x is equals to r plus 1, r plus 2, and so on.
Good morning, sir. My name is Ricky Calipes, and ang re-report ko is hypergeometric distribution. A set of n objects contains k objects classified as success and n minus k objects classified as failures. A sample of size n objects is selected randomly without replacement, which means which means hindi po siya hindi po siya nauulit, or hindi po siya nauulit. Then yung ano niya po,
Yes,
yung success and failure, hindi po siya. Tsaka ano po siya, not independent. Hindi po tulad ng binomial na independent. Yung hypergeometric distribution po is hindi po siya independent. Which means
Mali. Hindi siya independent. Independent siya. Or not dependent siya sa ibang values or dun sa success or failures.
ay opo. Sorry po. Tulad pala siya ng binomial na distributions na ginagamit to conduct multiple trials ng success and failures. Ang kaibahan lang po ay yung yung trials po is dependent sa sa each other po. Then yung parameters po is m is the size of the population, k is the number of items which the desired characteristic in the population, and the small n is the number of samples drawn. Next po. And the random variable x that equals the number of success in the sample is a hypergeometric random variable, and it is denoted as f of x, k choose x, then quantity n minus k over n minus x divide over r minus 1, and the x is maximum of or max of 0 n plus k minus n to minimum of k and n. That's all po.
Okay, kung buti na lang hindi ka na nag-example kasi medyo mahaba talaga to pero medyo pang hardcore na tong hypergeometric. Pero okay na yan. Kasi sa high level lang naman talaga yung kailangan natin dito para dito sa hyper geometric. So yung
Okay,
mahalaga
thank you po.
yung binomial saka yung itong next year yan, Poissons. Sino na yan?
Hello po, sir. Erica Naval po. A Poisson probability distribution is useful for describing the number of events that will occur during a specific interval of time or in a specific distance, area, or volume. Example of such random variables are next. So meaning the Poisson distribution is a discrete distribution that measures the probability of a given number of events happening in a specified time period. Example, the number of traffic accidents at a particular intersection, the number of house fire claims per month that are received by an insurance company, the number of people who are infected with the AIDS virus in a certain neighborhood, the number of people who walk into a barber shop without an appointment. Next. Poisson distribution versus binomial distribution. Under the supposition that the other assumption common between these two distributions hold the main one being independent. The following draws a distinction between them. Next. Poisson, whenever there are infinitely many values that our uncertain quantity, say x, can take, then x is Poisson distributed. For example, the number of vehicles that come by a gas station within between 9 a.m. to 11 a.m. X can take values 1 to infinity. So, sa Poisson distribution, yung attempts niya or yung trials niya is unlimited. And unlimited din yung possible outcomes. Binomial, whenever the experiment is performed for a specific amount of times, then we can be sure that our uncertain quantity is binomially distributed. For example, tossing a coin for n number of times, x can take values from 1 ton. So, yung binomial, fix yung attempts and yung possible outcomes ng binomial, dalawa lang. It's either success or failure. Thank you po.
Yung sa Poissons kasi more of mass data yung kino-consider niya. So mas malawakan yung probability. Unlike yung Poissons nga yun, definite. Ito na yata yung formula yan. Formula nung na Poissons.
Good afternoon po. My name is Erin Nicolas and I'm here to discuss about Poisson distribution yung formula po. Alright, so as you can see, ito nga po yun, yung formula ng Poisson distribution where yung x po, ayun po yung yung number ng occurrences or yung success. Then yung quick note lang po, sa iba pong textbooks or dun po sa ibang sources, ginagamit po nila dun sa may yung iba po yung ginagamit nila hindi po lambda. Ginagamit po nila is yung yung symbol po ng mu. Pero in Poisson distribution naman po, they're the same thing or parehas po sila ng meaning. Alright.
Yep, tama kasi yung mu parang product siya ng lambda. So yun.
Yes po.
Itong lambda sa yun yung product equivalent ng mu. Tama lang.
So, ayun nga po, yung lambda po, ayun naman po yung average rate of expected value. Then, ayun nga, Yung Euler's constant po, ano po yan? Ayan po yung value niya is 2.71828. Next slide, please.
Yep, sa calcu, pag prines inyo, diretso na yan. So, kahit di nyo kabisaduhin.
Okay, so para po ma-appreciate natin lalo yung Poisson distribution, ito po yung sample problem. A small business receives on average 12 customers a day. What is the probability that that business will receive exactly 8 customers in one day? So, katulad nga po ng sinabi ko kanina, yung lambda nga po, ayun po yung average rate. So, as you can see, yung average nga po nakasulat dito sa problem is 12. And yung success nga po, or yung name na is 8, kaya po siya x. So, t of x is equal to x and equal to lambda raised to x, then multiplied by e raised to negative lambda over x factorial. So, ang gagawin nyo lang po is, nyo lang po. Lagay nyo na lang po yung mga given dyan sa mga Then, and po yung kakalabasan is 0.0665. Yan. Tapos multiply nyo po, para po makuha yung yung percentage, multiply po natin ng 100. So, and po yung sagot. Therefore, the probability of receiving exactly 8 customers in one day is 6.55%. Then, next problem po, please. Next slide. Alright, ito po yung isa pong example. As only 3 students came to attend the class today, find the probability for exactly 4 students to attend the classes tomorrow. As I said last time, yung average nga po is yung nga po, ayan, yung 3. Then, yung nga po, yung goal na, or yung success na hinahanap is yung 4. Yan. Kaya, ayan po, lagyan nyo lang po, simplify. Lagyan nyo lang po yung mga, mga given dyan sa, Then, ayan po, multiply uli ng 100. Then, makukuha po natin is 16.03%. And yun lang po.
Yan na yan. Wala na. YouTube ba na? Okay, sige, okay lang.
Let's look at some examples of some common discrete probability distribution problems. I'm going to assume that you've previously been introduced to these distributions, and we're simply going to work through a few examples, although not necessarily in the order given here. For a military mission, engineers are creating an expensive system that relies on an important component. This component is very delicate and fragile and has a probability of failure of 0.32. That's a very high probability of failure. So to mitigate the risk, they install 6 of these components in such a way that they work independently. And they're connected in parallel so that if any one of these 6 components works, the system works. What is the probability exactly one of these components works? Let's let the random variable x represent the number of these components that work. We want to find the probability that x takes on the value 1. But what is the distribution of x? Well, here we have a fixed number of components, 6. And the probability that any one of these individual components fails is 0.32. So the probability that any one individual component works is 1 minus that, or 0.68. And it's said here that the components work independently. If that's meant in a probability sense, that knowing whether one component fails or not doesn't change the probability of any other component failing, then all of the conditions of the binomial distribution are satisfied here. We have a fixed number of independent trials, each one with the same probability of success, and we're counting up the number of successes. So here, the random variable x has a binomial distribution with n equal to 6 and p equal to 0.68. Now let's do the calculations. Here's the binomial distribution probability mass function. And we want to know the probability that our random variable x takes on the value 1. And so that's going to be our n of 6, choose 1, times the probability of success, our p, 0.68, raised to the first power, times our probability of failure, 1 minus p, or 1 minus 0.68, raised to the number of failures, which is 6 minus 1. And when rounded to 4 decimal places, this works out to 0.0137. So that's the probability that we'd have exactly one component work. But that's not really a very interesting question in this scenario. Let's look at a more important question. Recall that the system works as long as at least one of the 6 components works. So the most important question is, what is the probability x is at least 1? Because this is the probability that the system works. And that's going to be the sum of the probabilities of 1 through 6. So we could calculate these 6 probabilities using the binomial formula and add them up. But that doesn't sound like too much fun to me, and there's an easier way. The possible values of x are 0 through 6. If we want the probability that x takes on a value from 1 to 6, x bigger than or equal to 1, the only other possibility is x equaling 0. So the probability that x takes on a value that's at least 1 is simply going to be 1 minus the probability that it's 0. And this is equal to 1 minus the binomial probability mass function evaluated at 0. Or in other words, 6 choose 0 times 0.68 raised to the 0 times 1 minus 0.68 raised to the 6th power. And since 6 choose 0 is 1, and 0.68 raised to the 0 is also 1, this simplifies to 1 minus 0.68 raised to the 6th power. Or in other words, 1 minus the probability that all 6 fail. So we could have taken a bit of a shortcut here and simply answered this using regular probability rules and not relied on the binomial formula. All of this works out, when rounded to 5 decimal places, to 1 minus 0.000107, and that is simply 0.99893. That is the probability the system will work on this mission. A certain union chapter has 32 male and 26 female members, for 58 members in total. An important committee of 7 people needs to be struck, and the president of the union says they will randomly select 7 of the members to be on the committee. Whether that's a good idea or not is another question, but that's what they're doing here. What is the probability there are exactly 6 women on the committee? Let's let the random variable x represent the number of women selected to be on the committee. We want to find the probability that x takes on the value 6. But what is the distribution of x? It doesn't say here explicitly, but the sampling here is done without replacement. We're simply not going to pick the same person to be on the committee twice. Each person can only be on the committee once, so the sampling must be done without replacement. There are 26 successes in the population, the 26 females, and 32 failures, the 32 men. We are sampling without replacement and counting up the number of successes, so x has the hypergeometric distribution. When answering these probability questions from the hypergeometric distribution, I strongly recommend that we just think it through and don't rely on the formula. It's just easier that way for most people. Here we want the probability that the random variable x takes on the value 6. And the denominator of our hypergeometric formula is going to be the number of possible committees we can choose. And we're picking 7 people from 58, so the denominator is simply going to be 58, choose 7. In the numerator, we need the number of ways of getting exactly 6 women and 1 man. We need to pick 6 women from 26, so we're going to start out with 26, choose 6. And from the 32 men, we have to pick 1. So 32, choose 1. Using a calculator or software, we can find out that that is 0.0245 when rounded to 4 decimal places. How about a slightly different question? What is the probability the committee contains at least 6 women? Here we want the probability the random variable x is greater than or equal to 6, which is the probability it equals 6 plus the probability it equals 7. And we calculate each one of those probabilities using the hypergeometric probability mass function. On the last slide, we worked out the probability that x equals 6. And for the probability x equals 7, it's very similar in spirit. The denominator once again is 58 choose 7. But here we need 7 women, so from the 26 women, we must pick 7. And from the 32 men, we have to pick 0 because we're only picking 7 people in total. And when rounded to 4 decimal places, our final answer works out to 0.0267. Suppose a beverage manufacturer, as part of a marketing gimmick, puts tiny gold flakes into a beverage container at a rate of 800 flakes per 1 liter bottle. A 1 liter bottle is randomly selected, shaken vigorously, and a 10 milliliter sample is immediately drawn. What is the probability it contains exactly 2 flakes of gold? Well, let's let the random variable x represent the number of gold flakes in the sample. Here we're counting up the number of occurrences of something in a volume, and that should start our minds thinking about the Poisson distribution. But we also need some other conditions to hold, like these flakes occurring randomly and independently throughout the liquid. Since the container is shaken vigorously, then it's pretty reasonable to think that the flakes are distributed randomly and independently throughout the liquid, at least approximately. So here it's pretty reasonable to think that x will have, approximately, a Poisson distribution. Lambda is the mean number of flakes in the given volume, and here we're sampling a 10 milliliter sample from a 1 liter bottle, which is 1,000 milliliters. So our sample is going to be 1/100th of the liquid in the bottle. And each bottle contains, on average, 800 flakes. So a 10 milliliter sample, on average, is going to contain 8 flakes. The probability mass function for the Poisson distribution, the probability the random variable x takes on the value little x, is equal to lambda raised to the x times e to the minus lambda all over x factorial. Here we want the probability that the random variable x equals 2, that there's 2 flakes in our sample. And that's going to be lambda of 8 raised to the second power times e to the minus lambda, or e to the minus 8, all over 2 factorial. And when rounded to 4 decimal places, that's 0.0107. There's about a 1% chance that we get exactly 2 flakes in that sample. A European roulette wheel has 18 red slots, 18 black slots, and 1 green slot. It's reasonable to assume that the ball is equally likely to land in any one of the 37 slots. And suppose we want to know the probability that the first time the ball lands in a red slot occurs on the 5th spin of the wheel. We'll let the random variable x represent the number of spins needed for the ball to land in a red slot for the first time. And here the big key is that we're interested in the first time it lands in a red slot. And x is going to have the geometric distribution here. The geometric distribution is the distribution of the number of trials needed to get the first success in independent Bernoulli trials, like we have here. For the geometric distribution, if we want the probability the random variable x takes on the value little x, well, we first need x minus 1 failures, so that's got to be 1e raised to the x minus 1, and then on the x trial we need a success, so that's just going to be multiplied by p. And here we want the probability that x equals 5. And there are 18 red slots and 37 slots in total, so the probability of success on any individual trial is 18 out of 37. The probability of failure is going to be 1 minus 18 out of 37, and we need to raise that to the 4th power, 5 minus 1. And then we're simply going to multiply that by the probability of success, which is 18 out of 37. And this works out to 0.0338 when rounded to 4 decimal places. How about this one? What is the probability the first time the ball lands in a red slot occurs at some point after the 6th spin? Well, conceptually, this is pretty straightforward. If we want the probability x is greater than 6, we add the probabilities of 7 and 8 and 9 off to infinity. But we can't actually add an infinite number of probabilities together without using some sort of mathematical trick. And here we could also say that the probability that x is greater than 6 is going to be 1 minus the probability that x is less than or equal to 6. And we could calculate that without too much difficulty here. But that involves calculating 6 geometric probabilities. The probability that x equals 1 and 2 and 3 and 4 and 5 and 6, adding that up and subtracting that from 1. So I don't really want to do that either. I'm going to use a helpful bit of logic here. If the first 6 spins are not red, the first red must happen after the 6th spin. So the probability that x takes on a value greater than 6 is equal to the probability that the first 6 spins do not result in red. And so the probability that the random variable x takes on a value bigger than 6 is going to be the probability an individual spin does not result in red, which is 1 minus 18 over 37, raised to the 6th power. So just the probability we get 6 non-reds in a row. And that, to 4 decimal places, is 0.0183. We'd get the same result if we did it this longer way, which involved calculating 6 geometric probabilities. Tom is part of a production process that makes an expensive piece of high-tech equipment. If Tom makes a mistake, the equipment will be destroyed at a high cost to the manufacturer. Tom is good at his job and on average has a probability of 0.001 of destroying an individual piece of equipment. But Tom is a bit shaky psychologically, and if he destroys a piece of equipment, he gets rattled and is more likely to destroy other pieces he works with. What is the probability that Tom destroys exactly 3 of the next 20 items he works on? Here, a lot of the conditions of the binomial distribution are satisfied, and you might have thought of that. We have a fixed number of trials, 20, and we're counting up the number of successes, which is him destroying a piece. We have a probability of destroying any individual piece, but here the number of destroyed pieces would definitely not have a binomial distribution. There's a key line here, and that if he destroys one piece, he is more likely to destroy other pieces. This means the trials are not independent, and independence is a required condition for the binomial distribution to hold, and it's not true here. So the number of destroyed pieces would not have a binomial distribution, or any of the other distributions we've discussed. The situation's simply more complicated than that, and this question is not answerable with the given information. We'd need to know more about the nature of the dependency, and it would be a complicated question. That leads to one final thought. Not every random variable has a nice, simple distribution. One could even argue that in reality, almost all don't. Very often, our probability model is simply an approximation to a more complicated underlying reality.
Meron pa, ano, Carmela? Yun na yun.
May isa pa pang video.
Ilang minutes yan? Parang same din yun kanina eh.
5 po.
5 minutes? 5 ba? Sige, play mo. Okay. So, nandiyan naman yun dyan. Ayan, no, ayan ba yun sa dulo? Yung link, no? Okay. Wala na magdi-discuss ano. Okay na yun. Last part na. Bella?
Apo sir, tapos na po.
Okay, so mas ano siya. Okay, so thank you dun sa mga nag-report, no. So I think na-cover naman nila lahat, no. From random variable and probability distribution, cumulative, expected. Actually, ano, nadagdagan pa nga nila. Yung sa geometric dapat medyo kahit di na nila diniscuss pero sinama na nila, no? Kasi part nung sa binomial, no. So yung binomial saka yung Poisson's distribution. No? So I think na-cover naman nila lahat and they gave a good example naman, no. So good job dun sa mga nag-discuss. So ang challenge lang doon is yung how do you use the formula, no? Kasi hindi lang pwedeng kabisado nyo yung formula tapos magsasagot na kayo ng problem. So dapat yung kada function or kada parameters ng formula alam yung gamitin. Kung kailan magiging successful or success or failure yung formula. Kung kailan nyo gagamitin yung Q, kailan nyo gagamitin yung P, then kailan nyo gagamitin yung mga mu sa lambda. So doon madedevelop yung ano nyo, yung conceptual analysis no sa formula or sa analysis sa mga problem solving. So idadissect nyo yung problem, then bago nyo sagutan yung problem, ililist down nyo lahat ng given. So ayun mas magandang way, no. Then find the required, then solve and analyze na, no. So they gave an example naman kada topic. So ang minakita lang ako example na i-share ko na lang sa DA natin sa LMS is about more of dun sa discrete part naman. So share ko na lang yung YouTube video. Then I think after the discrete, next reporter naman is next week, no, by yung discrete, so more of definite probability. Next is yung continuous naman. So I think yung continuous same to na magiging tema nung discrete, no. So ayan, nandito rin yung normal approximation about binomial and Poisson's distribution. So sino nga yung next na yun? CPE. Ako na save yung wala. Teka. Groupings. Sino nga yung group to nyo? CPE yan. Sila, ayun, si Bulataw. Parang wala yata dito na. O, nandito ba? Alam ko nagpa-review. Ayan, dyan na pala. Alam ko nagpa-review na to eh. So, next week na kayo ha? Ano? Rhea, ready na ba? O may kulang pa?
Dadagdag pa po.
Ayun. Na-review ko na yung ano mo, di ba, file? Bulataw. Ayun, may nakalimutan. Ayun. Then, ayan. Siguro upload ko na lang yung quiz pala natin, no? So, yung quiz 1 and 2 nasa DA na. May nakita ko na-take na eh. So, mukhang nadalian lang sila. So, tatlo yung may nag-take na ng quiz 2 eh, no? So, yung quiz 1, more of objective. Yung quiz 2, that is more of computation. Then, upload ko na lang yung file dito sa module ng discrete probability. Itong report nila, pati yung recordings. Any question? Clarifications? May question ba kayo sa reporter? Or may hindi kayo naintindihan? Si Isabel nag-heart. Yung iba wala? Or yung iba wala talaga? Naka-join lang talaga? Or Mia, missing in action ng iba? Wala? So, nagets nyo? Ano yun, De Rosas? Wala? Okay. Nice. Ako rin, kahit ako naganda kasi though may mga high level lang example, pero napakita naman nila yung kung paano gagamitin yung mga parameters. So which is yun yung pinaka first thing or yung basic foundation sa pag-solve sa probability. Ayan, sige, pakayo ng camera para may tayo. Attendance. Stop na natin tong recording para mag-save na. Tayo lang natin yung iba. Kayo ilan nga kayo? 50 plus ba kayo? Nalilito ako sa inyo. Kayo ay 59. Yun. Kayo pala yung pinagsama rin pala. Okay, nasaan iba? Tago, tulog. Kailangan, isin lang natin yung gallery. Si Mela, bigla nag-on ka mo kanina, hindi nag-on ka, ma'am. Budo lang. Okay. Tayo lang natin, naglo-load pa yung iba. Ayan. Tingnan natin, may update sa ano eh, sa face-to-face eh. Gusto niyo na ba mag-face-to-face?
Medyo
Opo.
po. Opo, sir, hindi.
Pero hindi ko alam kung pwede tayo. Basta sabi pwede daw i-request pero i-check ko kay Dean. Okay na. Okay lang. Dun screen ko lang. 1, 2, 3. Ilalagay. Apa. 1, 2, 3. Ayun. May question pa kung wala na. Medyo paggabi na rin. So, humayo kayo at magpakarami. No? Sige po, sir.
Thank you po, sir.
Thank you po, sir.
Thank you,
Salamat.
sir.
Thank you po, sir.
Thank you, sir.
Okay, save ko muna yan. Okay. Nabuhayan ng iba eh, no? Kanina, mga tulog yan lahat.